We are DMA 60, and today our objective is that we're going to look at sections 3, 4, 5, 6, and 7. These sections we are going to work with polynomials. We're going to talk about what polynomials are, and we're going to look at how to add, subtract, multiply, and divide polynomials. When we have a polynomial, this is where if we have, let's say, x squared, if we were to have, let's say, 3x, if we were to have, even if it's just a number, -4, each of these items we call a term. Term just simply means it's the product of numbers and or variables. And when we write a polynomial, we are going to separate the terms with either a plus sign or a minus sign. So these are just simply terms. If I wrote it as a polynomial, it would be x squared. Both of these are positive, so it'll be plus 3x. That's a negative, so that would be -4. So this itself is called a polynomial with the pluses and minuses. These three particular items would be called the term. Another word that we will be looking at is the word coefficient. The coefficient is the number is the number of the term. So, for example, for this first term, there's not a whole number here. The understood whole number would be a 1. So the coefficient of this term is a 1. The coefficient of this term is the number 3. And the coefficient of this term would be considered the whole thing, the -4, okay? So the coefficient I have underlined here in blue. Another word vocabulary that we will look at is the word degree. Degree refers to the exponent. The degree of this first term, we have the degree of a 2. So that is the degree of this polynomial. This particular item does not have an exponent, so it's an understood 1. That would be the degree of that term. This one, we don't even see a variable. If you recall from our lecture the other day, if you ever have something to the power of 0, x to the 0 is technically the number 1. And 4 times 1 is still the -4. The degree of the whole number is going to be the value 0. That will be the degree. When we have polynomials, we have special names for some of them. The three terms that I'm going to look at are monomial, binomial, and trinomial. If you look at each of the prefixes, mono, bi, and tri, that will help you to know what the definition of those would be. Mono means 1. So a monomial is made up of one term. The prefix bi, as in bicycle, which has 2 wheels, would be 2 terms. The prefix tri, as in tripod or tricycle, would be 3 terms. So an example of each of these, a monomial could be just simply 3x squared. A binomial with 2 terms could be, let's say, 3x squared plus 4x. A trinomial with 3 terms could be 3x squared plus 4x minus 7. So one term is a monomial, 2 terms is a binomial, 3 terms is a trinomial. All of them are polynomials. And if you have more than 3 terms, we just generically use the word polynomial. When we are using polynomials, we will have to do a process just like we did in DMA40, a process which is called combining like terms. So even as I'm talking about now combining like terms, this is going to lead up to what we're doing in section 4, which is adding and subtracting polynomials. When we combine like terms, let me give you, and I'll use one of the examples from your workbook on page 6-28, question number 7. I'll go ahead and do the one where we have those fractions. We have 4/3 x to the 4th minus 5x cubed minus 1/3 x to the 4th plus 7/10 x cubed plus 3/10 x cubed. So right now, if you will, turn to page 6-28. We're working on question 7. When I look at these problems, and if you look at how they write them in the workbook or the viewing example, they're going to give you a much more lengthy way to write out all these things. I don't do that. To me, it's a lot of busy work. I like to mark on the problem that we have. The like terms here are the ones where the variable x has the same matching exponents. The highest exponent, and we always want to write our polynomials in descending order of exponents. So we look for the biggest exponent. The largest exponent is x to the 4th. So what I'm going to do is I'm going to put a square around both of the terms that have x to the 4th. They would be considered like terms because the variable and the exponent both match. All we have to do now is to combine the 4/3 and the minus 1/3. This is where, when you have fractions, please just use your mathematical tool. It's like our math hammer. We're going to use our calculator. So we're going to take 4/3 and we're going to subtract 1/3. For some of you, if you're not as familiar with the calculator, let me show you how you can type the fraction in. If you do alpha y equals, and we're going to choose number 1, I'm then going to type in 4/3, press the right arrow to make the cursor come out from up underneath, minus alpha y equals, choose number 1, and then type in the 1/3. So we're doing 4/3 minus 1/3. That gives me a solution of just the whole number 1. Okay? So when I combine these terms, I get 1x to the 4th. The 1 is not necessary to have to write, but I'm just going to write it as a placeholder here. Then we're going to combine the like terms that all have x cubed. So I'm going to put circles, and do you notice I'm circling the sign also? You need to circle that too. We're going to do -5 plus 7/10 plus 3/10. So down here is our negative, -5 plus, we're going to do 7/10 plus 3/10. Okay, and that gives us a -4. So that means our other term is going to be minus 4x to the 3rd power. So combining like terms is going to be either adding or subtracting the coefficients of the terms that have the same exponents. In section 4, this is addition and subtraction of polynomials. That whole section is technically what we just did in our example for combining like terms. If you will look on page 6-31, let's look at problem number 2. On problem number 2, we are given 3x squared y minus 4xy plus y. We're going to add to it x squared y plus 2xy plus 3y. When you have an addition problem, you may rewrite the problem and just drop the parenthesis, because if it's addition, none of the signs are going to change. So this is what you would see on the computer or in your workbook. When you write it on your paper, you just write it without the parenthesis. Now, if you would like to, if it makes you happier, I do not mind. Like this term did not have a number. If it makes you more comfortable to come write a 1 there and here to write a 1, if you feel more comfortable that you won't forget to use a 1 there, please feel free to write it. It's absolutely fine to do so. So my first like term that I'm going to add is going to be the one that has the x squared with the y. These are the two items that have x squared with a y. So we have 3 plus 1. There was no number, so we have to add the understood 1. That gives us 4x squared y. Now we're going to combine the x, y, where it's just a single x, a single y. So we have -4 plus 2. If you want to check yourself, go to your calculator, do -4 plus 2. That gives us a -2. So we would have minus 2xy. And then last, we have a 1y and a 3y. 1 plus 3 is going to give us 4y. So with addition, drop the parenthesis, and then you're going to combine those terms. For subtraction, when we look at subtraction, if you will, turn over to page 6-33. For this one, we have here an x cubed plus 2x plus 6. Then we have a minus, and we have a negative 3x squared minus 5x plus 3. For the first term, you're just going to drop the parenthesis. So that's x cubed plus, no, excuse me. Oh, that is x cubed, okay. X cubed, I'll just make sure I didn't miscopy it, plus 2x plus 6. The first one, we just dropped the parenthesis. However, hang on one second. With the second part of the question, if you will notice, it's minus, and then we have a parenthesis. With subtraction, you have to do something when you remove the parenthesis. What we're going to do is here, this is like a -1, and we are going to distribute the -1 to all three of these terms. When we distribute that, it's going to change the signs. So negative times negative would give me a positive 3x squared. Negative times negative would give me a positive 5x. A negative times a positive would give me a minus 3. So the only difference is the first parenthesis is dropped, it's positive, there's nothing in front. When you have a subtraction problem with a parenthesis, you change the signs of everything in the parenthesis when you drop that parenthesis. Now, just combine like terms. As we mentioned earlier, we use descending order. Descending order. So the largest degree would be the x to the third. There's only a single x to the third. There is only a single x squared, so the x squared would come second. I then have a 2x and a 5x. When I combine those terms, 2 plus 5 is going to give me 7x. And then the last two like terms is the 6 minus 3 is going to give me a positive 3. That entire polynomial is your final answer. There is nothing more that you can do to that. You are just simply going to look at it, make sure all the like terms were combined, and then we cannot do anything else. This is an expression, and we're just simplifying those expressions, okay? As we move into section 5, 5 and 6, both of those sections are multiplying polynomials. Multiplying polynomials, you'll find, is very easy. What I'm going to start with is I'm going to give you two polynomials, and this is from page 6-37. We have 2ab squared and a negative 5a to the 7th b to the 4th. Okay? So the first thing that we're going to multiply is we are going to take the two numerals. The parenthesis beside a parenthesis means multiplication. There are no pluses or minuses. So 2 times negative 5 is going to give us a negative 10. When we look at the a and the a to the 7th, when we multiply the same base, remember the rules we learned Monday is that we add the exponents. So we were going to add a 1 plus 7, which would give us a to the 8th. Then for the b's, we're going to add the exponents 2 and 4. That would give us 6. So that's it. Okay? We multiply the numerals, and then when we have the same base being multiplied, we add the exponent. So this is just two single monomials that we're multiplying. Now, if we have, let's say, a monomial, this is on page 6-38, 2x squared y times 3x squared minus 5xy plus 7y squared. We are going to, in this case, use what we talked about in DMA 40 called the distributive property. We are going to take the first term times what's in front times the first term. Then we're going to multiply it by the second and then by the third. When we do the distributive property, I want you to keep in mind, you are going to multiply, and I want you to ask yourself, what is the sign? Is it positive or negative? Positive or negative? Is there a number? Write down what the number would be. And then is there a variable? And remember, the variable means the letter. And if we do have a variable, we'll have to use that rule to add the exponents. So for the first one, we have 2 times 3 gives us 6. We have x squared, x squared. 2 plus 2 gives me x to the 4th. Here's a y, there's no y here, so we only have a single y. That will be our first term. Then we're going to distribute it with the second one. 2 times negative 5 would give us negative 10. For the x, we have 2 and 1. That gives me a total of 3 x's. For the y, I have 1 and 1. That's going to give me y squared. For the last term, we have 2 times 7. That's a positive 14. There's an x squared here. There's none there, so it's still x squared. For the y, we have 1 and 2. That gives us y to the 3rd. And then that's it. That's all that we're doing there. So if it's one term times a polynomial in a parenthesis, you're going to use the distributive property. Okay, next, we're going to look at multiplying two binomials. So if we have two binomials, we are going to use what's called the FOIL method. The FOIL method is what you will hear your Math 171 teachers talking about. They'll say, FOIL these polynomials. So this is what we're going to do when we FOIL something. I'm going to choose one of your examples from over on page 6-40. I'm going to choose number 6. We have 5x minus 1, and we have 2x minus 7. We have two binomials. There's two terms, and here's two terms. They're both in parentheses, and we are going to multiply those. FOIL, the F stands for first, the O stands for outside, the I stands for inside, and the L stands for the last. So when we FOIL, we multiply the first terms in the parenthesis. Outside would be the outside terms. Inside would be the inside terms. And last would be the last terms in actual parentheses. So we'll label these as we go through. These two would be the first. So we have 5 times 2 is 10. X times x is x squared. So you look at the parentheses, and the 2 in the first part of each parenthesis is the first. The outside would be the two outermost ones with the whole problem. 5 times negative 7 is negative 35, and then we have an x. The inside is going to be the two innermost ones inside the parentheses. So we have negative 1 times 2x. Negative 1 times 2 is negative 2, and we have the letter x. And then last, the last is going to be the last term in each parenthesis. So negative 1 times negative 7, negative times negative gives me a positive 7. So when you FOIL, you multiply first, outside, inside, last. And then all we're going to do now is I'm going to write down combine like terms. So this is the first term, highest degree, 10x squared. These two in the middle happen to both be like terms. Negative 35 minus 2 is negative 37x, and then our last term is plus 7. So when you have two terms, we're going to FOIL those. Now, sometimes we're going to have maybe 2 terms times 3 terms, 3 terms times 3 terms. So if you will look on page, let's say 6-41, I'll do an example where we have, and whether we did 2 or 3, the process is going to be the same. I'm just going to pick the one with 2 so I don't have so much to spread out on this little screen. Okay, so if we have, let's say, 5a minus 4 times 3a squared minus 2a plus 7. When I do ones with multiple terms, I like to write them so they appear to be like this problem, where it looks like you're just going to distribute. So to make this appear to be a distributing problem, I would take my 5a, and I'm going to multiply it by what's in parentheses. And the parenthesis is the 3a squared minus 2a plus 7. Then what I'm going to do is I'm going to take this minus 4, and I'm going to multiply that by everything that was in the parentheses, the 3a squared minus 2a plus 7. So I took the first term here, the second term here, and I just multiplied it times the entire second polynomial. So as we distribute, 5 times 3 is 15. A would be 1 plus 2 is 3. 5 times negative 2 is negative 10. 1 and 1 would give me a squared. 5 times 7 is positive 35, and I only have a single a. On the second one, I'm going to do the same thing. Distribute here. Negative 4 times 3a squared is negative 12a squared. Negative times negative is a positive. 2 times 4 is 8, and I have the letter a. Negative 4 times 7 is negative 28. So all we did was rewrote it, and then we distributed. Now we're going to combine like terms. This is the only a cubed. So I'm going to write down 15a cubed. I have negative 10a squared and negative 12a squared. So negative 10 minus 12 is going to give me a negative 22. So I would have minus 22a squared. I'm going to combine 35 and 8. So 35 plus 8 gives me 43. So that's plus 43a. And then this numeral is all by itself, so minus 28. Now, since we have a lot of terms here, do you notice when I mark mine, I make a marking on every single one as I go? That way, when I finish the problem and I look back, I can visually see, did I miss combining a term? So if you make marks on each of your terms as you go, that's going to help you so that you can easily do these, okay? Now that's everything in section 5. Now in section 6, if you'll turn in your workbook to page 6-45, this section is on squaring binomials. I'm going to show you the formulas that you can feel free to memorize to use when you square binomials. However, the way I normally do these is I would write them down twice and then FOIL. Okay? So if we have a plus b and it's going to be squared, that would give me a squared plus 2ab plus b squared. If you had a minus b squared, that would give you an answer of a squared minus 2ab plus b squared. Let me give you an example of how you could do this. So here, let me do it in a different color. This is just an example. If I had, let's say, 3x plus 7, and I wanted to square it. This is the a, this is the b. So if I took a and squared it, I would take 3x and I would square it. For the middle, I would do plus 2. My a is 3x, my b is 7. And then the b squared, my b is a 7. I would take that term and then square it. To get your final answer, 3 squared is 9, x squared. Here, 2 times 3 is 6, and then we would have 6 times 7 would give us 42x, and then the last term, 7 squared, would give us 49. So you can memorize the formulas and you can apply using the formulas, or I'm going to take that same problem. That problem was 3x plus 7 squared. The way I would do it is I would FOIL it. So that means squared, I multiply it times itself. So I'm going to write it down 2 times. Then I'm going to go through the process of FOILing. First, 3 times 3 is 9. X and x would be x squared. Then when I do my outside, the outside 3 times 7 is going to be 21 with an x. My inside, 7 times 3x is going to give me a plus 21x. And then My last 7 times 7 is going to give me 49. Combine the two middle terms, and my final answer is 9x squared plus 42x plus 49. All of section 6 is showing you this new formulas that you can memorize, those two that we showed for squaring a binomial, or you could simply write it a second time, and once you write it a second time, you would then simply FOIL it and combine like terms. The next thing that we are going to look at is section 7, and section 7 is divided polynomials. Divided polynomials, when you have one term in the denominator, is fairly simple. If you look on page 6-54, let's look at question number 3. Okay? No, we'll start with a different one first. Let's start with question 1. We'll do question 1 first. Question 1, we have 6m squared minus 9m plus 12. They write it over 3. I don't like to leave mine written that way. The way I do it would be 6m squared over 3 minus 9m over 3 plus 12 over 3. I like to write it that way so I can mark on each problem and then simplify. So for this first one, 3 goes into 3 once, it goes into 6 twice. So that leaves me with 2m squared. 3 goes into 3 once, it goes into 9 3 times. I'm left with minus 3m. The last one, 3 goes into 3 once, it goes into 12 4 times. My last term is plus 4, and you're finished. I don't like to write it once because what I find that students sometimes do is they divide the 3 by only one of those terms and then they stop. Now, if it's a single term, you're thinking, well, that's not that big of a deal. It's not. You probably will still do that correctly. But if you have a problem such as number 3 on page 6-54, this problem is 12x to the 5th y to the 4th plus 9x cubed y minus 3xy. All of it is over 3x squared y. Now, for this problem, I would ask you to rewrite it. And this is the way I would write this one. I'm going to make this one really visual for you. I would write down my 12. I would write my 5 x's, my 4 y's. I'm going to put it over 3, my x squared, and my y, plus 9, my x cubed, y, over 3, x squared, y, minus 3xy over 3x squared y. I like to write this one out the long way because when you have a lot of variables, it'll just make it easier to see what you have left and where it is located. So 3 goes into 12 4 times. Now, I have a pair of x's that cancel out, and I have a single y that cancels out. I'm left with 1, 2, 3 x's. So I still have 3 x's left, and I still have 1, 2, 3 y's left. Here, 3 goes into 9 3 times. Here I have a pair of x's, another pair of x's, and a pair of y's. I'm left with just a single x. For the last term, the 3's cancel. One pair of x's, one pair of y's cancel. Now, in this case, there's nothing in the top, so that would technically make it an understood 1. In the denominator, we just have that single x. You can't just put minus x. You would have to leave it as 1 over x. Okay, so that is our division when you have one term in the bottom. Let me do an example of one when we have long division. So let me come here. There aren't any examples in the book, and this is one of those things, if I make up a problem, it's not going to be one that's going to work out. So give me just one moment. I will write one of these down from the homework section in my Labs Plus. So for a problem like this, we have a polynomial divided by x minus 2. So when I write it down on paper, I'm going to put the x minus 2 as my divisor. So I'm going to have x minus 2 here. It's going to go into the polynomial that was on the top, which is 2x cubed plus 4x squared. Whoop. 2x cubed plus 4x squared minus 19x plus 3. Minus 19x plus 3. Okay, so for long division, it's just going to be like regular long division you would do with whole numbers. We have two terms, and it's going to go into the first two terms. So I'm going to start my answer here. What you want to create is figure out what do you multiply by the first term to get the first term. Our objective is to make the first term cancel out each time. So to get a 2x cubed, I would need to multiply x times 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. Now, pay attention here. When we draw our line, we are going to change our sign. Because remember, what you're doing here is you are going to subtract. So if I subtract a positive, it becomes a minus. If I subtract a negative, it's going to become a positive. So that becomes a plus. So 2x cubed minus 2x cubed, that cancels. That was our objective. Here, that was a plus. 4 plus 4 is 8x squared. Bring down the next term. Now we have these two terms, and now these are the two terms it goes into. So we're trying to create this 8x squared. What do you multiply x by to get 8x squared? A positive 8x. 8x times x is 8x squared. 8x times negative 2 is negative 16x. Then we're going to draw the line and change the signs. This becomes a minus, this becomes a plus. Our objective is for the first term to cancel, and it does. Negative 19 plus 16. Negative 19 plus 16. Always double check yourself. That's going to give us a negative 3. So we have negative 3x, and we're going to bring down the plus 3. We need to figure out what do we multiply x by to get negative 3x. Well, we multiply by a negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. If I have a positive, personally, I do not write the plus sign. Because if I wrote the plus, now when I draw my line and change my signs, I'd have to come back and erase it. So this minus becomes a plus. What was a positive is going to become a minus. And then we are going to see that the first term cancels, which it should, and 3 minus 6 gives me a negative 3. To put my remainder up here, I'm going to write plus -3 over x minus 2. So this divisor goes in the denominator. A remainder is, this is the remainder. The remainder is always in addition to. So just write a plus sign. Whatever this is, put that in the numerator. This becomes the numerator. And this is going to be the denominator if you have a remainder. And that is it.